Hello and welcome to this lesson video on dozers, their types, capabilities, and production estimation. This video covers the shown three learning objectives. Dozers are one of the heaviest and most powerful earthwork equipment, which moves the soil by pushing it, not carrying it. This is why dozers have no identifiable volumetric capacity like trucks or scrapers. Dozers are used in different applications like site clearing, soil pushing from cut to fill, ripping, and assisting other equipment like scrapers or even other dozers. Let's see some details of material pushing using dozers. Dozers can be used for stripping the organic topsoil. Larger dozers on cohesive soils can push the material for longer distances. Dozers can also be used for backfilling by using the angle blade or pushing the soil toward the fill area with an angle. The dozers can help in spreading the soil that's dumped by other hauling equipment like dozers and scrapers. Finally, dozers are equipped with rippers on their backs to loosen the ground to be moved by other dozers or scrapers. Dozers can be on wheels or tracks. Wheeled dozers are generally lighter and faster, but require favorable soil conditions and surface. Crawler dozers are more heavy and move on tracks, and this is why they can handle tougher soil types but at much lower speeds. We can clearly see the difference between wheeled and crawler cranes by examining their performance chart. The left chart is for wheel dozer, while the right one is for a crawler dozer. The first big difference is the speed. Wheel dozers can travel up to 33 km per hour, while the crawler dozer travels up to only 10 km per hour. The higher speed of the wheel dozer requires having more engine gears. There are 4 gears compared to only 3 gears for the crawler dozer. The second big difference is power. The crawler dozer can exert around 72,000 pound draw bar pull or usable power, but wheel dozer can only provide 54,000 pound rim pull. So in summary, wheel dozers can provide higher speeds, while the crawler dozers provide higher push power. Another difference between wheel and crawler dozers is related to the best surface to drive each dozer. Wheeled dozers with rubber tires have very high surface traction on flat, strong surfaces like concrete or asphalt, but crawler dozers have much lower traction on the same surface type. This traction comparison is flipped on the clay natural surface, where crawler dozers have more traction than wheeled dozers. The dozer blade can have 3 degrees of movement freedom. The blade can tilt to provide the required slope in the cross-section plan. The blade can pitch up and down to control the angle and depth of the soil cutting. Finally, the blade can angle around the vertical axis to help in side casting the soil, while the dozer moves along the side of a fill area. Dozers can be equipped with 4 blade types for different operational needs. The straight blade, or S blade, is the common and standard type of general dozer pushing operations. The angle blade, or A blade, can be angled and enables the dozer to perform side casting of the soil. A universal blade, or type U, is longer than the straight blade and can push more soil with the help of its bent side edges. Finally, the cushion blade is used when pushing another equipment from the back, like scrapers. Here are some photos of the blade types. Let's watch and analyze the Dozer production. From the video, we can model the Dozer cycle to follow 3 simple steps. The Dozer starts by pushing the material forward and then backtracks to the start of the push line. And then do some maneuvering to adjust the direction of blade for the new push. So the Dozer production can be calculated as the production of a single cycle, which equals the output over input. The cycle output is the blade load of soil being pushed in loose cubic units, and the input is the sum of the 3 cycle step times. Let's see how to find the each term in the production formula. The push and hold times both follow the same relation of distance over speed. You can get the distance from the side geometry or the average hold distance from the mass diagram. The push speed is typically dependent on the soil type. The Dozer has a relatively faster speed for loose soil types, as shown. You can figure out the return speed from the Dozer performance chart by knowing the total resistance. The maneuvering time is a small value and it can be assumed to be 0.05 minutes. The last value that we need to calculate to be able to use the Dozer production formula is the blade load. Let's see the different ways to calculate it. The dozer blade load can be estimated based on simply the experience of the project planner, superintendent, or machine operator. Another way is to use the manufacturer's blade rating. The shown formula are provided by a famous equipment manufacturer for its dozers, and they calculate the blade load for straight and universal blades. For straight blade, the pushed volume is dependent on the blade width and height. The universal blade includes the same calculations of the straight blade, plus an additional term to account for the extra soil held by the blade side angles. A third way to calculate the blade load is to use empirical field measurements using the shown formula. This way requires actual measurement of a sample soil push, which might not be feasible in some projects that require early pre-planning before the actual construction begins. This empirical approach is more relevant in validating those dozer production rates. We can use the production curves published by the equipment manufacturer. The shown chart is for Caterpillar dozers, where each curve relates the average dozing distance to the production rate of a specific dozer model. For example, a D7H dozer pushing the soil for 300 feet will have a production rate of 200 loose cubic yards per hour. The dozing production estimates are calculated for ideal conditions and should be revised to reflect special operational conditions. The shown table provides some production correction factors to adjust the estimates provided by Caterpillar. Let's see some examples of these correction factors. We can see the large correction factor of 1.2 to reflect the positive production gains when pushing a soil that's already stockpiled. We can see similar positive production gains in the case of slot dozing and side-by-side dozing. However, small correction factors are suggested for hard soil types. This chart shows the impact of grade on the dozing speed. The larger the factor on the vertical axis, the faster the dozer will push the soil. It's clear that pushing upward on a slope will reduce the dozing speed. Dozers are really heavy equipment with serious blind spots and limited visibility. The dozer operators are required by OSHA to buckle the seat belt to avoid dropping from the seat due to the great vibration during the dozer movement. Also, a good buffer distance should be kept between the dozer and any excavation edge to avoid serious safety incidents like the one shown in this photo. Generally, clear visibility for the dozer operator should be maintained and sufficient lighting should be provided in night operations. This concludes this lesson on dozers. Thank you for watching.